Hi guys, welcome to Joshua's Tech Tips. So in this video, we're going to take a look at what is an IP address. IP address stands for Internet Protocol Address. Some of the features of an IP address are: it makes communication on the internet possible. All devices on the internet need an IP address to communicate, as well as each device has a unique IP address. So to give you an idea of how IP addresses work, we're going to take a look at how our postal service works. So if we refer to this diagram, in order to send mail, first you have a sender, you have a recipient, and you would have the mailman. So the sender would have a sender address. So in this example, the sender's address is Joshua's Tech Tips, number 55 Orangefield Crescent Street, Trinidad. In order for that sender to send that mail, they will need to have a recipient's address. And the recipient address is John Doe, number 123 Main Street, USA. By the way, these addresses are fictitious, so please don't try sending any mail to either one of them, because chances are you won't get responses. So by that process, the sender is able to send a mail to the recipient. So the sender needs to have a sending address, then you will also need to have the recipient address for this process to work. If you didn't have the sender's address, once the recipient receives the mail, they will not know who to return. If they need to correspond with the sender, they wouldn't know who to correspond to. Similarly, if the sender doesn't have the recipient's address, it wouldn't know who to send the mail to. Again, with postal addresses, similar to IP addresses, they are all unique. So similarly, how everyone would have a unique postal address, so too on the internet, everyone has a unique IP address. So now we have me trying to communicate with Google. So similarly, how the post office would work, we both have unique addresses, unique IP addresses. My IP address is 181.118.63.152. Google's IP address is 8.8.8.8. So when communicating with Google, I would be using Google's IP address to send information to. Similarly, when Google wants to communicate with me, it would be using my IP address to send information to. So IP addresses consist of 4 sets of numbers separated by dots. This is what we refer to as dot decimal notation. So computers actually don't understand this dot decimal notation. They refer to IP addresses in their native format of binary bits. So essentially, to a computer, an IP address is 32 bits because it's 4 sets of 8 bits, which would give you 32 bits. So this is the binary expression of this IP address we are seeing on the screen right now. So you may ask, well, why do we use dot decimal notation? Because as humans, it's much easier for most of us to write dot decimal notation. For instance, 172.16.254.1 than write the binary equivalent. Wouldn't you agree? So as I mentioned, everyone needs to have a unique IP address to communicate on the internet. So if that's true, how many are available? So to find that out, there's a simple calculation we can use. 2 to the power of 32. So how do we get this calculation? Remember, a binary character could only be represented either 2 ways, a 0 or a 1. So that gives us 2 possibilities. So that's where the number 2 comes in. And the number 32, we get that from, remember, there are 32 bits in an IP address. So that's where we get the number 32 from. So if we calculate 2 to the power of 32, this would be the equivalent number of IP addresses we can get, which is 4,294,967,296. With the introduction of smartphones and smart devices and smart homes, etc., these IP addresses are almost gone. So to mitigate that, we have two options. So option one is something called NAT, which stands for Network Address Translation. So remember I said to communicate on the internet, each one of our devices need a unique IP address. But could you imagine our internet service providers having to give us multiple addresses for each one of our devices? In some cases, we may be using a dozen public IP addresses. However, what NAT does, it allows us to use our one public IP address to resolve requests to our private IP addresses. So private IP addresses are what we use in our internal network, for example, our home, our office. This is what we use, private IP addresses, to communicate internally. These addresses cannot communicate directly to the internet. They are what they call non-routable addresses. Most of you all probably are familiar with this 192.168 scheme. This is a popular IP address scheme. So through the process of NAT, we would have to have a NAT device. So in our example, it's a router. So say for instance, we wanted to send a request to Facebook using the first computer, which has the 192.168.1.2 address. This request would come to our router. Our router would then send it out using our public IP address, which is the 202.45.1.1 address, to Facebook. Facebook would then respond back to our public IP address, our 202 public IP address, and through the process of NAT, this would then come to our original computer which made the request. And this is what makes network communication or internet communication possible. We don't necessarily need individual or unique public IP addresses for each one of our devices. Through the process of NAT, which would be able to use our one public IP address to send and receive data. I'll be doing a video sometime in the future where we take a more in-depth look at NAT. Our next option is something called IPv6, which stands for IP addresses version 6. So essentially we've been discussing IP version 4 so far in this video, which is the most popular form of IP addresses that we currently use. However, IPv6 would be replacing IPv4 in the near and distant future. So unlike IPv4, which uses dot decimal notation, IPv6 actually uses hexadecimal notation. And this is an example how one of the addresses would look. With hexadecimal, our address pool is much bigger. So the calculation for that is actually 2 to the power of 128. This in turn will give us 340 trillion addresses. So needless to say, we should be safe many years to come when we start using IPv6. And that brings us to the end of this video. Remember to like and share. Also, if you like the content I'm creating, be sure to subscribe to my YouTube channel and click on the notification bell to be notified once a new video is released. Thanks again for viewing. See you soon.